Hello and welcome to IGCSE Mathematics 0580 extended course, syllabus topic E1 number, module E1.5, and it's about fractions and decimals, and we are doing part 4, exercise 4 of chapter number 1. And as we know, we are using a book, Complete Mathematics for Cambridge IGCSE extended syllabus, written by David Rayner. In question number 53 to 60 is asked us to convert recurring decimal to fractions. Simply speaking, in fact, this number is 0.66666 and so on. This is a recurring decimal. I mean 6 is repeating itself infinitely times, is never ending. So instead of this, we write in a smart way 0.6 and put a dot on top of it, right? So now we have to convert this decimal number into fractions. Now guys, this is a technique, a very simple one, to convert any recurring decimal into fraction, which is, look, first of all, you have to write this number equal to any variable. Let's suppose I take a variable x. Just place that number x equals to 0.6 and it's a dot on it because this 6 is repeating itself, right? The second, which is the most important part, is that you have to multiply on both sides, right? You have to multiply with both sides. And what is that number? It depends how many decimals or how many digits are recurring. So only 6 is repeating itself. Look, see, 6 is repeating itself. So it's only one digit. One digit means you have to multiply 10 on both sides, right? Let's suppose if you have 0.676767 and so on, in that case you have 0.6 and 7 dot and dot. It means that 6 7 is keep repeating itself. If it is let's suppose if it were given 0.67, so what we're gonna do, we have to multiply this time with the 100 because there are two digits which are repeating or recurring itself, right? So depending on the recurring decimal or digits, you take the 10, 100 and so on. So because there is only one digit this time, it means you have to multiply 10 on both sides, right? So multiply with the 10, it on the left side you have 10x, on the right side when you multiply, now just quickly one thing, let's suppose you have a number 0.56 and you multiply with this number with the 10, right? So what happens, in fact, this decimal, when you multiply with the 10, this decimal will move one place to the right because there is only one zero. So this decimal will place one place to the right. So the answer will be 5.6, right? And the same goes here. You are multiplying 10 on this side. Let me quickly write it down like this one. You are multiplying 10 on both sides, and as we know, as from the algebra, if you perform the same operation on the both sides of the equation, it won't affect. So you're multiplying on the left side of the equation and you're multiplying right side the same number on both sides, so it won't affect the equation at all. So 0.66 is multiplying with the 10. See, this number is multiplying with the 10. It means that this decimal will move there, right? And the answer will be 6.666. So I will write 6 dot on it, right? So once again, what I did, I multiplied 10. How did I take 10? Because only one digit is repeating itself, so I'll take as 10. Multiplying both sides, it will become 10x and it will be 6.6 and keep on repeating itself, right? Now we have two equations, 10x equals to 6.6 and we have x equals to 0.6, and this is the recurring decimal. Now what you have to do, you have to subtract these two numbers, right? You have to subtract. 10x minus x is 9x, left from the left side, right from the right side, and 6.666 minus 0.666. So of course once you subtract it, these two will cancel out, so you only left with 6 minus 0 is 6. So you have left with 9x equals to 6. So x equals to 6 over 9. If you can cancel out to make it more simple, so 3 2s are 6 and 3 3s are 9. So the answer is x equals to 2 over 3, right? So guys, so this is the answer. Okay, now look at that question 55. It says 0.12, and see that we have a dot on two digits now, 1 and 2. It means that in fact this number is 0.12, 12, 12, and so on. See that this time the repeating digits are 2. 1, 2 is repeating itself, so that's why we have written the starting with the 1 and ending with the 2. So it is repeating like that. So it means, just keep in mind, two digits are repeating this time, right? So as we know, the first step, we have to put this number equal to x. So x will be equals to 0.1 and 2, and 1 and 2 are recurring decimals. So we know that the two numbers are repeating this time. It means you have to multiply with 100 on both sides. So 100 on this side will make 100x equals to, now see that if you multiply 0.12121212 with 100, right, as our understanding, this decimal will move to the right to the two decimal places, so 1 and 2. This decimal will move here, so it will be 12.121212 and keep on like that. And we have abundance of 1 2, it is never ending, so it will be, if you multiply 0.121212 with 100, it will be 12.121212. So it will be 12.12, and these are the recurring decimal, right? So in the same way, you have to subtract it, x equals to 0.12. as we have already discussed, to subtract two decimal or add two decimal number, the decimal part should be on top of each other, like this one. This should be on top of each other. Now you have to subtract these two, left from the left side, right from the right side. So 100x minus x is 99x, right? And that is equals to, see, this 1 2 1 2 1 2 and this 1 2 1 2 1 2 will cancel out. We are subtracting, so this will cancel out, and 12 minus 0 is 12, and you are left with x equals to 12 over 99. If you can simplify quickly, so yes, it's going on 3 tables, so 3 4s are 12, 3 3s are 9, 3 3s are 9, so it's 4 over 33. So the fraction part is 4 over 33. If you quickly want to see with the calculator, you will have exactly this pattern, 0.121212, keep on repeating. So 1 2 are the recurring decimals. In question number 57, we are given with 0.134, and we can see there are three dots. It means three recurring decimal numbers. So it means, in fact, this number is 0.134, 134, 134, and so on, right? So the same technique. So first of all, we have to decide how many digits or decimal places or numbers are recurring. There are three this time, right? 3 mean you have to multiply with the 1000, simply speaking. So it means, first of all, let's put it in front of x. So x equals to 0.134, 134 recurring, multiply with the 1000 on both sides. So this is 1000x, and of course, you know, once you multiply this with the 1000, it means this decimal will move three places this time. So 1 2 and 3, it will be here, so it will be 134.134, and so on. So it will be 134.134, and these are the recurring decimals. So once again, you have to subtract both sides, left from left and right from right. So 1000 minus x is 999x, and these part will cancel out. 134 minus 0 is 134, and the x will be equals to 134 over 999. These cannot be further simplified, so this is our answer. Question number 25, it says 0.25 and 5 is a recurring decimal. It is a very interesting situation. See that we have, first time we having a decimal number in which on the right side 2 is not repeating, only the 5 is repeating. What does it mean? In fact, this is like this one, 0.255555 and so on. It means, see that 5 is repeating itself, not 2. So it means that this is not a standard format. Standard format is that on the right side of the decimal you should have only and only the repeating pattern. It means somehow you have to move this 2. First of all, place it in front of x. So let's x is equals to 0.25, and this 5 is recurring decimal, right? So first mission is that to write in a standard format. As we know, in the standard format mean on the decimal part we should have only those numbers which are repeating. So it somehow we have to move this 2 to the right first of all, right? So in order to move that, we have to move this decimal here. So you have to multiply 10 on both sides, right? So if you multiply 10 on both sides, so it will be 10x, and that is equals to 2.5 decimal 5, and this is repeating. See, multiplying with the 10 means this decimal has moved here. Now this is a perfectly a standard format. So now you can just apply the same technique, and we know that how many digits are repeating. Only one digit is repeating, so you are going to multiply once again with the 10 number. So actually your procedure is starting from here. This is your starting point now, because first of all you have to write this 0.25 and 5 is a recurring decimal into a standard recurring decimal format. Now you multiply with the 10 here, so 10 is already here. 10 times 100x equals to, now see that if you multiply you have like 2.555 and so on, and you're going to multiply with the 10 this time. 10 means this decimal will move to the one place to the right, right? So it will be 25.555, right? So it means multiplying with the 10 here is 25.555, or you can write like 5 dot and don't need to write this one, right? So once again you have to subtract, so this from this. So let me write it on underneath this. It is 2.5, and then this dot is recurring decimal. So you have to subtract these two numbers. 100 minus 10 is 90x, and we know that subtracting means this will cancel out with this one, and 25 minus 2 is 23. So it means x equals to 23 over 90, and this cannot be further simplified. So this is the fractional representation of 0.25, where 5 is a recurring decimal. So in the last question, which is question number 60 of exercise 4, we are given with 0.617 and 17 are the recurring decimals, right? So it means that this number in fact is 0.6171717 and so on, right? So again, the first step is, let's put it in front of x equals to 0.617, and 1 and 7 are recurring decimal. Again we have the same trouble. We as we know, in the standard format, on the right side of this decimal we should have only and only repeating digits or repeating decimal or recurring decimal, and we have this 6. We have to sort this 6 out. It means we have to move this 6 onto the left side. Is only one digit, so we have to multiply first 10 on the both sides. So it will be 10x equals to 6.17, right? Now it is clear. So it means that you have a number of 6.171717 and so on. So how many digits are repeating? Two digits are repeating, so it means you're going to multiply with 100 on both sides. So 100 into 10 makes 1000x equals to, look 100 multiply means this decimal will move to the see, you are going to multiply 100 here, so this decimal will move two parts to here, so it will be 617.17 and keep on repeating. So we can write 617.17, and 1 and 7 are the recurring decimal, and we're going to subtract this is our original equation. We're going to subtract 10x equals to 6.17, and these are the repeating decimal. So subtracting on both sides, 1000 minus 10 is 990x equals to, as we know, this and this will cancel out each other. 617 minus 6 is 611. 611, and x equals to 611 divided by 990. So this is the fractional representation of 0.6, 1 and 7, where 1 and 7 are recurring decimals. In the next videos, we'll be talking about the next syllabus topic, which is E1.6. So see you there.